Now we're going to be solving linear equations. I know you've done this in the past, but we've got to do it again. So we're going to solve each equation algebraically, which means by hand, and then we're going to check the answer, preferably on the calculator because it's quicker. So in the first problem, if you'll notice, I have got parentheses, and if you remember, we've got to use the distributive property. So I've got to distribute the 5 through to everything inside on the left, and on the right a negative 2 through. So on this side I should have a 5x minus 10, and on the right hand side a negative 2 plus 2x. So let's see if I do. Okay. Now when you're solving linear equations, you have got to get the variables to one side, your constants to the other. So I'm going to subtract 2x, so I'll have 3x on the left. I'm going to add 10, so I'll have 8 on the right. Now if you have to do additional steps to get this correct, you do it. But normally this is how you'll see it done in class. The next thing, I've got to solve for x, which means gets it all by its lonesome. I'm going to divide both sides by 3. And so my answer should be x equals 8/3. So let me get my calculator. Let's store in 8/3. And now I'm going to type in the left-hand side how it was in the original problem. And when I hit enter, this is what I get when I substitute 8/3 in. Now let me type in the right-hand side. If I end up with the same thing, then I've done the problem correctly. Yay! Okay, so that's my answer. So I usually put a little tiny check mark. So 8/3, that works. Now let's look at the next problem over here. I've got an equation and I've got denominators. Our first job is to clear out the fractions. So my common denominator would be 15, so I'm going to multiply the left-hand side by 15 and the right-hand side. Sort of similar to what we did in problem 1. So I'm going to multiply 15 times the first term and 15 times this one. A lot of my students forget that, but you've got to be careful. So first thing I'm going to do is indicate what my plans are. And if you'll notice, I put 15 in front of each term. So 5 into 15 will go 3. 3 into 15 will go 5. And with us doing that, I'm getting rid of the denominators. So I'm going to rewrite what I have left over. Don't go down there. And if you'll notice, it is like number 1. I'm going to distribute the 3, so I'm going to have 9x minus 3 minus 30 on the left and 10 minus 5x on the right. Anytime you use the distributive property, and if you can combine like terms, you need to do so because it shortens the problem. Like before, I'm going to move the x's to the left, my numbers to the right. So if I add 5x, I'm going to have 14x. And if I add 33 to this side, I'm going to have 43. So 14x equals 43. And now I'm going to divide by 14. So x equals 43 over 14. So let me pull up my calculator again. So 43 divided by 14, storing for x. Type in the left-hand side. Now when you have a rational expression, then you need parentheses, and not around the fraction, around the numerator and the denominator. So I'm going to have 3x minus 1, that's my numerator, close that, divide by 5. Now subtract 2, so that's my left-hand side. Let me see what I get. Let me put in the right-hand side, so parentheses, 2 minus x, divide by 3. And if I come up with the same thing, that means 43/14 is my answer, and I do. So that's my correct answer. Okay? So let's see what I have under here. If solving a linear equation leads to, now there's 3 possibilities actually. First, if it leads to a true statement such as 0 equals 0, notice there are no variables. The equations are called an identity. its solution is all real numbers. So anything you can think of, you substitute in, you'll get a true statement. If it comes up a single solution, such as x equals a -2, the equation is conditional. It's on condition that you use the correct answer or number that will make the statement true. Its solution is a single element. Now the first two problems we did, those are conditionals. The last possibility is if you come up with a false statement. Notice again I have no variable. 3 does not equal -7. This is called a contradiction. Its solution is no real numbers. So in this next part we're going to solve each of the following algebraically. Check your answer if possible. So I'm going to multiply through by -0.3 here and a positive 0.4 here. So if I do that, this will give me a -0.3x plus 1.5. And on this one, I'll have a plus 0.4x minus 2.4. So let's see if that's what I've got. Okay. Combine like terms. This gives me 0.1x when I have that -0.3x and plus 0.4x. So that's a plus 0.1x. And a positive 1.5 minus 2.4 gives me a -0.9. Now, check this out right here. Notice that the left-hand side and right-hand side are the exact same things. If you actually graph these, they're the same line. If you put this one in y1 and this one in y2, they share all points. Now, if I go ahead and solve, get my x's to one side and numbers to the other, look what happens. I end up with 0 equals 0. And that just is an indicator saying that regardless of what I put in for x, everything works. So my answer is all real numbers. Now let's look at the next one. Distribute and see what you come up with. And see if you come up with what I do. Pause me if you need to. Combine like terms. That gives me a -15x, and a -6 plus 12 is a plus 6. But now look at this one. If you put this part in y1 and this part in y2, they have the same slopes, different y-intercepts. These lines are parallel. They will never have a point in common. But let's go ahead and get x's to one side and numbers to the other. So you end up with 0 equals -5. No way. That's a false statement, a contradiction. My solution here is no real numbers. Okay? Thank you. That's it for this one.